Welcome back to my channel, everyone. 3 Tips here, and it was Thursday evening, and I was trying to figure out what I wanted to do to post a video for Friday night, and I had a large 6-liter stainless steel bowl that I had purchased, and so I grabbed a lid from a 5-gallon bucket here and tried to make a cutout so that we could fit a food cup down in there to create an anode basket and a lid for the silver cell. So that's what I'm doing here, cutting that thing off. My first attempt was a fail. The thing broke on me. So I redid it, and I used a block of wood underneath there to support it so it wouldn't break. And so now we have an anode basket. I was going to use this 5-gallon bucket lid as the cover for it. But I cut the hole too big, and now it doesn't fit in there right. It leaves a gap, which I do not want. I want it to fit in there a little more snug than that. So I think what we'll do is I've transferred the image of the hole onto the cover that came with the stainless bowl. But this thing is right flimsy. I don't know if it's going to be able to support all that weight. I may have to modify this, but for right now, we're going to go ahead and cut this, and we'll use this as our cover for the silver cell. Here you can see this is a much better fit for the anode basket. Kind of wedges in there, prevents any junk from falling down into the cell. But the problem is it's kind of flimsy, and so what I may do is just cut this out and then lay it in here on top of this lid for a 5-gallon bucket to give it some support. Let's see how this thing fits in there. I've got to trim a little off. I left a little material on there so that we could trim it and get it right. Because you can always take some off, but you can't add the material after you've made the cut. So we'll trim this up and get it to fit down in there perfectly. Here we go. We've got it trimmed up. I think that's going to work out just fine. So we now have our anode filter basket fitted into the lid of the silver cell. All right, let's do a check fit on this. This white piece is a 5-gallon bucket lid that I cut a hole in the middle of it. And now I've got this spacer piece in here, so we've got a nice snug fit. This is going to be holding about maybe 2 pounds of silver or so. So I think that should do it. That should support the weight and act as the cover for the silver cell. We've got a 6-liter cell, and I want about 150 grams per liter. So I'm going to use 1,000 grams of pure silver. Divide that by 6. That should give me 166.6 grams of pure silver dissolved in a liter of liquid. So we better get started on this first, because this is going to take the longest amount of time. I'm going to tear our beaker to 0. All right, this is the pure silver crystal that we just harvested off of our dual silver cell harvest. I'm going to use this for the electrolyte. I need 1,000 grams of this pure silver crystal. With 1,100 grams in our beaker. Now what we'll do is we'll take this out and dissolve this silver in nitric acid. This should take a while. Let's go out to the fume hood. Here we go. Let's go ahead and dump our silver into our large 4-liter beaker. Now we're going to cover the silver up with some distilled water. So what we'll do is we're going to just set this up out of the way on the burner, but I'm not going to turn the burner on. I've got 1,100 grams of pure silver. And I think it takes about 0.9 milliliters to dissolve 1 gram of pure silver. So it's looking like we need 990 milliliters of nitric to dissolve all that. But I don't want to dissolve all of it. So what we're going to do is I'm going to measure out about 900 milliliters of nitric acid. And pour that right on in. Now what I'll do is slowly start adding the nitric acid into this silver to get most of it to dissolve. Man, I don't like the way this beaker pours. When I'm working around the camera, I gotta be careful not to touch the wires to interfere with the sound on the camera. I've got 2 cameras running right now. I've got a time-lapse camera running. And so I wasn't able to get back in there and see when I was pouring this out. If you pour it too fast, it overflows the spout and then drips down the side of the beaker. There's some heat being generated by this reaction. I haven't added any additional heat yet. Let's go ahead and see if I can get this poured in there correctly without spilling it. If you pour it at the correct rate, it won't spill out like I did the first time. Just kind of pour it in real slow. So we've got 300 left. I've got 600 milliliters of the nitric acid in the silver now. I've pointed this out in previous videos. The color you see there is from the way the light is reflected when we add that nitric acid. The nitric acid causes that color change. I can't explain what it is, but it's not contamination. You'll see when we get done, the electrolyte should be colorless like water when we get done. Our electrolyte is very close to being complete. I'm going to add some more silver just to make sure that we've got all of the nitric consumed in there. and let this cook for a while longer. Here is a time-lapse sequence of the entire dissolve of the pure silver crystal with hot nitric acid. I'm using a 50-50 solution, roughly, of nitric acid and distilled water to dissolve that 1100 grams of pure silver crystal. And the sole purpose of the electrolyte is to provide a medium for these silver ions that dissolve up in that anode basket, for those silver ions to travel through that electrolyte and then deposit as high purity silver on the inside of the cathode. The stainless steel bowl is the cathode. Now the silver in the electrolyte is not supposed to deposit on the cathode, but as the cell runs, that electrolyte becomes depleted of silver because it does deposit on that cathode. And so what I'll have to do is periodically, as the cell is running, I'll add some additional silver nitrate electrolyte to increase the silver concentration in the electrolyte. I've had the silver on boiling now for probably 6 hours, and I don't see any more fume production going on in there. So it's fairly safe to conclude that we've got the silver dissolved and all the available free nitric used up out of there. Notice there's still some silver left down in the bottom of the beaker. So now what we're going to do is reach in here, grab this, and pull it down. Set it down here and let it cool off. This electrolyte was made from the pure silver crystal that we harvested from the dual silver cells a couple days ago. As you can see, it's crystal clear, colorless, which tells me I've got some high purity silver from those silver cell harvests. Here's our stainless steel bowl that we're going to use as the cathode. I've got a magnet here. It's non-magnetic. These are the stainless bowls that I'll be using for the cathode for the silver cell. Got these at Costco. I just realized that I don't have any impure shot for the silver cell. So what we'll have to do is get some melted up cement silver in this bucket here. It's just an aluminum tank of water. I've got a submersible pump, and what I'll do is put that down in here. Then I've got a little ramp that I've built, and stick that in the handle, and then that'll provide a place for me to pour the silver onto, and it'll spatter out into the water. This is the discharge from the pump. Got a screw and a piece of tubing, and I just connect it to the top of the ramp here. And what that'll do is that'll shoot the water down on the ramp to keep it cool so that it doesn't burn when I pour the molten silver on it. I'm gonna dump some water in here. This is just tap water. And I will energize the pump and start pumping water over that board. Restrict the flow by pushing down on it with this little clip of metal. There we go. That's what we want. We want that water splashing on the board. There we go. That's perfect. I need a little more water, but I've got to save some room in here because I'll be adding some ice. Here we go. We're going to charge the crucible up with some cement silver. This is silver that I recover from my gold refining that I do. And then what we'll do here is we'll go ahead and bring in the MAP gas torch to start the melt, and then we'll finish it with oxyacetylene. But right now I'm going to go get my mask on because I do not want to breathe these fumes. Here I'm using the oxyacetylene torch to melt that silver, and what happened is it kept clogging the nozzle up. And so when you see that drawer come open, I've got to scrape the junk off the nozzle and then poke the holes out so that the gas will flow. And I think I had to do that 3 or 4 times while I was melting this silver. But I still prefer doing it this way. It's convenient. I know what I'm doing. I grew up with a oxyacetylene torch in my hand, so this is my preferred method. If you look right here, there's a crack in my crucible. So this crucible is done. Now let's get this water off of here and get our silver shot dried out so we can use it in our new silver cell. And I think what I'm going to do is just set it out here in a container outdoors. Let me tilt this up and get this water drained off of here. We'll just let that dry now. We used an organic method to dry our silver off. Put it in this pan and put it out here in the sun. Now let's gather it up in these containers and get a weight on it. Got another scale here. This feels like it's going to be too heavy for the other one. This is only 2,000 grams max. Let's see what we got here. Oh yeah, we got 3,470 grams of impure silver that we melted into shot from our cement silver, and we'll use this as the feedstock for our 6-liter silver cell. Just to be clear, the reason I have 2 supports for this is because when I cut this one, I made it too big. See how it moves around in there? So I went ahead and cut this one out. This one by itself would be too flimsy. I don't think it would support all the silver that we're going to have in our anode basket, but it does give a nice snug fit. So that's why I added this piece, so that we can get the nice snug fit of the black piece and have the support of the thick white 5-gallon bucket lid. So that should support some heavy weight there. Now what we'll have to do is figure out how we're going to fit these anode filters in. This is a shop vac Dacron filter bag, and it looks like this. Turn it inside out to get the tag out of there. And then I think what we're going to have to do is kind of just force this down in here like this, and then maybe trim away the excess material. Here's a comparison size difference between the new 6-liter cell and the 3.5-liter cell that we've been using successfully for about 13 and a half years. And so we're going to try to go a little bigger here with the 6-liter cell and see how that does for us. I've got the electrolyte ready. Now what we need to do is come down here and figure out how we're going to configure these this anode filter. I think I'm just going to put it in here like this. Push it down in the best I can. Like that. Alright, let's get a fresh razor blade. Let's see if we can go around here and just cut through this. I don't know how this is going to come out. This is our first time doing this. I hope it stays in there. That might work. Now we're going to add some shot. What the heck is that? Well, we might as well document this. I made an error. This is not our anode basket. This is our anode basket. So now I've got to try to pull this out of here. Okay. All right. Phew. That saved me a little time anyway. All right, here we go. I'm going to pour in the electrolyte. Now we're going to add distilled water to the 6-liter mark back here. Here we go. stir this up. I've got a little bit more water here to get it to the 6 liter level. There we go. And now what we'll do is stir this up, make a nice consistent mixture here. Let's put the top on this thing. Boom. Now we're going to lower our anode basket down in there with our impure silver shot in it. Alright, so far, so good. I've got a brand new anode electrode bar. And what we'll do now is we're going to set this up and use this, hooking the anode electrode bar up to the positive pole on the power supply. I've got this thing coiled so that it exerts a downward force on the bar as the silver dissolves out of that anode filter. Filter material off here with a sharp razor. Here we go. We've got a moment of truth here. I've got the 6 liter cell all set up and ready to go. I'm scared to press this button, man, but here goes nothing. Let's see what happens. See, this thing is only a 6 amp power supply, and we're probably going to have more than that going through the cell. And if we do, I may have to switch over to this one, this smaller one. It goes to 10 amps, so I'll keep an eye on this. But it looks like we're in business. We now have a 6 liter electrolytic silver cell. The amps are still climbing. I think what I'm going to do is adjust this down to 3.4 volts to try to slow the thing down a little bit and see if that'll help us. We don't want that amperage getting too high, so we're going to run it at 3.4 volts for a little while. It's been running about an hour. We're up to 5.8 amps on this thing. I may need to adjust that voltage down to 3.3 volts just to make sure that I don't get too high on the amps. 3.3 volts is the low end of the range for the silver cell. It's been running now for about an hour. I've been editing the video so I can get it posted this evening. So let's look in here. It's been running for about an hour. Let's see what we got going on in here now. Oh yeah, look at that. We're growing some silver crystal in our 6 liter silver cell. Very nice. Look how small that 3.5 liter cell looks sitting next to the 6 liter cell. I'll probably end up having to melt some more shot. I don't know how fast this one is going to consume the shot out of the anode filter, but I'm guessing it's going to be faster than the smaller cell because we're pulling so much more amperage through the cell. So this will keep me busy keeping the shot melted up and ready to go in that anode filter, which is a good thing. I've got a whole bunch of cement silver laying around, and I'm just too lazy to get up and get it melted and get it going. So now that I've got a big silver cell running, I should be able to keep up with it a little better. Okay, this will conclude the 6-liter electrolytic silver cell build. Thank you for watching.